Okay, so this is my first lecture on OS. I'm not a lecture, so a study review on OS. So yeah, let me just show you what I've read today. I'm starting from the basics of OS. So yeah, today I have read something about you know hardware requirements, and yeah, let me just show you. So this is the book I've been following, and so yeah, today I have finished these topics. Okay, so yeah, and yeah, let us just get into it. Okay, so what the book uses in future to explain the operating systems and its applications are these two systems, hardware panels, you could say. One is Galileo and the other is Beagle One Mac. The Galileo uses x86 instruction set, which is from Intel, and the Beagle Bone uses the ARM's instruction set for its hardware. So both are system on a chip, which is like you keep everything in a single chip, which I have learned today. Like, yeah, I didn't really hear about it much, but uh, it's like you put a CPU and its RAM and all of that in a single chip, so that it could, you know, work as a processor and as a full general purpose computer, but without the IOs and other, you know, other requirements that you generally see in a computer. So both of them have a serial console, which is like a terminal which the OS could use to, interact or uh, send messages or errors to us, which you should be connecting to with, I think, the GPIO pins or something like that. I don't know what that is. So this is what the complete panel uh, in a logical way, right? This is generally, I think, is called an address bus, I guess. But yeah, you have a processor and memory RAM, as you can see here. So yeah, uh, yeah, both. So as we are working with OS, most of the OS code is in, you know, most people write it in C, so you don't exactly need to know the instructions set. ISA, like you only need it when you're working with the very basic assembly code. So yeah, there is that. So the components in this processor are there is general purpose registers which could be used by the processor, to do the arithmetic part or to store something. And for it to be concurrent, for it to run concurrent, processes. So the OS need to create an illusion that the process has full control of the processor. Uh, so it needs to, swap the registers with memory when you are running a process. So there's that which you will see in the future. Right. Okay. In Galileo, we have obviously there will be a program counter. The program counter is that uh, it points to the instruction that needs to be done by the CPU. I mean the processor. So I think most of the, I mean all of the processors would provide a program counter. And in addition to program counter, we have 8 other registers which the system provides. You can just see those. So what does 32-bit mean is that the registers are of 32 bits. Uh, so you could, you know, have 32 bits of data, play around with 32 bits of data. But Intel also allows you to, address specific bits, specific parts of the register. So you can only just like get the first 16 bits and maybe use it as a 16-bit register. So yeah, on the other hand, people won't use ARM 32-bit architecture. This also has a program counter with 15 other general purpose registers. When you say general purpose, it's general purpose for the processor, but the hardware uses it uh, for specific tasks, like the ASP, which is a stack pointer, which is used to used to return functions when you run the program. Uh, so next, we come to IO buses. What is a bus? A bus is generally refer to the hardware provider, which is used by the processor to interact with memory or IO device. Uh, so both, so what it generally does is use a faster processing. Uh, if the CPU wants to get an information, it just puts the address from which it wants the information from, and you know, and the memory then looks at that bus and then gives the memory, the information needed on the address bus and signals the CPU that okay, now the memory is ready here. You can take the information you need from the bus. So if you want to store something, this processor would signal store with it information and the address you want to store it in, and the memory sees that and takes it and stores it at that address. So both of this, like the Galileo and the black, whatever that is, Beagle Bone Black, right? Both of them use something called memory mapped IO, which is like each IO device, gets a virtual address. Uh, uh, like there is no real, they get mapped to some memory in the memory space. So when you access that memory space, you are indirectly communicating with the IO device. And in memory mapped IO, as in this case, uh, you can interact just like a Fitzner paradigm where if the CPU wants to, ask the IO to perform something, it just gives the IO device the instruction needed. I mean, the address of that instruction, I guess. I'm not really sure, but you get the intuition there. And then there is direct memory access, where you give the memory access to the device, IO device needed. Uh, so what it does is instead of CPU writing or the processor continuously waiting for all the work done, uh, I mean to read the address or from the memory. What it does is it the device itself, the recipe using the internet. My processor wants to wants a packet from the internet. The packets are uh, transferred as parts. The packet is divided into many pieces, and each piece is sent. So the CPU can't wait for the whole packet. So what it does is it just initiates a device, internet device, and says, okay, you take the packet and write it into my buffer. I will read it from there. Until then, I will do something else. So the CPU goes to do something else, and the DM waits and checks if the packet received was right, and writes it to the buffer, and then yeah, writes it to the buffer, and then signals the CPU. Okay, I have done it. Now you can use it. So now the CPU just takes it from the buffer and uses it. So basically, the CPU doesn't have to wait for all the work to be done. It can do something else. It's like a work. So yeah, that's mostly all of it for today from the OS part. And tomorrow, I plan to finish all these because I don't have any work tomorrow. Uh, okay, so let's talk about something else now. Mm, I have shit going on with me right now. I'm a little busy, so uh, I'm supposed to explain one of my topics to the professor tomorrow. So yeah, there is that. I think this book. I don't think so. No, this is not. Okay, it's just about uh, Corksters group combinator is a cluster group, and I'm supposed to read what the cluster group is and all of that to explain it tomorrow's lecture. And I have another thing called ethics. I don't know why they keep it in the name. Yeah, I get the basic idea, but yeah, I have to do that as well. And I haven't done any work in the last class, so all of the work is to be done by me for tomorrow's presentation. And yeah, so I have that on the. I will show it to you maybe tomorrow. The presentation I prepared on AQI case study. I haven't started it yet, but yeah, there is that. So yeah, we will meet again tomorrow and discuss more about her hardware and runtime development tomorrow. That's it. Bye. Bye.